Hello and welcome to this overview of the EMIT Viewer. This video is designed for EMIT Imaging service customers, as well as researchers working with data generated on the XERA Cryo-Fluorescence Tomography platform. The EMIT Viewer is designed to make it easy to visualize, navigate, and explore the anatomical and molecular fluorescence imaging data acquired during your CFT study. These datasets provide detailed 3D information at sub-organ level resolution, allowing you to explore fluorescence localization alongside the corresponding anatomical data. There are multiple versions of the EMIT Viewer available, with different options depending on how you want to access and work on your XERA data. The EMIT Viewer is a web-based tool that opens directly from a link in your browser. There is nothing to install, making it a simple way to access and explore your CFT datasets from any computer. The EMIT Viewer Pro is a desktop application that can be installed locally on your Windows or Mac computer, allowing you to load and explore XERA datasets directly from your local system. It is important to note that the EMIT Viewer Pro is designed primarily for visualization and exploration. If your workflow requires more advanced analysis capabilities, these are provided through our separate software solution, EMIT Analyze. Depending on your research needs, additional versions and features may also be available. Your EMIT account manager can help you identify the right viewer and software options for your specific workflow. In this video, we'll take a guided tour of the EMIT Viewer's core features and show you how they can help you navigate, visualize, and interact with your CFT datasets more effectively. Let's get started. Before we start exploring the data, let's quickly get familiar with the viewer layout. There are three main areas to be aware of. Across the top is the toolbar, where you can switch between the image planes, change your viewing format, navigate in 3D, and access additional viewing tools. On the left is the Channels panel. This is where you can select your anatomical and fluorescence channels and adjust how each one is displayed. And in the center is the main image viewport, where you'll navigate through and interact with your CFT dataset. Now that we're familiar with the layout, let's start by looking at the anatomical and fluorescence channels. A good place to start is with the RGB or white light image. This provides the anatomical reference for your CFT dataset and helps you orient yourself before evaluating the fluorescence information. You can use this auto contrast for a quick adjustment or fine-tune the minimum and max value display settings that you can see here. You can also set the image to grayscale if that would be preferred. Below the RGB image are the fluorescence channels acquired during your study. Simply select a channel to activate it. Multiple fluorescence channels can be displayed at the same time, allowing you to explore different signals together with the anatomical information. In this case, we have two channels that were acquired during the CFT acquisition. I will start focusing just with one channel only. Each fluorescence channel has a few simple controls that allows you to optimize how the signal is displayed. First is the exposure time. CFT datasets may contain several exposure times for the same fluorescence channel. Selecting a longer exposure time can help reveal weaker fluorescence, while shorter exposure times may be more appropriate for stronger signals. Let's choose 50 milliseconds in this example. As you move your cursor over the image in the viewport, the corresponding pixel value is displayed in the lower left corner of the viewer. This can help you determine whether the selected exposure is appropriate. If values approach roughly 55,000 counts, the image is approaching saturation, and a shorter exposure should be considered. You can also view multiple exposure times at once to confirm the optimal exposure using the tile view, which I will show later in this demonstration. Next is the lookup table, or LUT. Here you control how the fluorescence is colored on the screen. Choose your preferred color that makes your signal easy to distinguish from the anatomy and from any other active fluorescence channels. In this case, I will choose fire. Finally, the min-max controls adjust the visible fluorescence range. These controls change the way the signal is displayed. They do not change the underlying CFT data. This is useful for reducing background and bringing the fluorescence pattern you're interested in into clearer view. For example, if I make the maximum here 30,000, the image will appear brighter. If you also need finer control, you can narrow the slider range using the range settings below if you click on this expand tool. This will rescale your slider across your chosen range, making it easier to fine-tune the min-max values. For example, here our slider range is 0 to roughly 66,000. By changing the slider range here from 65,000 to 30,000, we can use the full slider to make finer adjustments within the range we're interested in. You can also use this eye icon to temporarily hide an image channel without removing your settings. This is particularly useful when you want to quickly compare the anatomy with and without a fluorescence overlay. You can then repeat this for the next channel loaded. Let's do that for the next channel. In this case, I'm going to select a different exposure time. I will select 500 milliseconds, and I will change the color to red so I can distinguish. In this case, I will also change the settings for the maximum value, and I'll change that to 30,000. Now you can see that this channel has now appeared on my white light and fluorescence channel overlay. There are several viewing options available for exploring your CFT data. The default is the plain view, which you can see here, which displays the active fluorescence channels overlaid on the anatomical RGB image. The side-by-side view displays each active channel separately, with each channel shown in its own panel, and this makes it easy to compare the anatomical RGB image with the individual fluorescence channels, or to combine multiple fluorescence channels directly with one another. The overlay view brings this information together, displaying the RGB image on its own, the active fluorescence channels overlaid on the RGB in the center image, and the fluorescence channels on their own. This is particularly useful for viewing fluorescence in the anatomical context. And remember, as you navigate through your data, you can use the eye icon at any time, like so, to temporarily hide a channel. This makes it easy to focus on individual signals or quickly compare your images with and without a particular fluorescence channel. Another useful option is the tile view. This allows you to display multiple images at the same time. For example, if your dataset contains multiple exposure times, like so, for the same fluorescence channel, you can display these together in the tile view by selecting each individual exposure time. This is a nice way to be able to compare the pixel values in your areas of interest, and this will help you then to select the most appropriate exposure for viewing your signal. As an example, if I click on this area of the animal, in this case, the pancreas, on the bottom left of the screen, we can see the pixel values for each of the different exposure times listed. In the tile view, you also have the option to toggle between different view formats, like so. Here we can see them all side by side, or vertically, or in a grid format. Once you've selected the exposure time you want to work with, you can return to your preferred view and continue exploring your dataset. Now, let's move through the dataset. Here I will focus on just one channel. I'm going to go into the plain view so I can see my fluorescence image overlaid on my RGB image. You can navigate through the individual slices using your scroll mouse wheel or the slider along the bottom of the viewport. This allows you to follow a fluorescence signal through the sample rather than evaluating only one single image. Here we are looking at the transversal view, but we can also toggle between the sagittal and the coronal views, like so. Here is the sagittal view, and here is the coronal view of the same mouse. After switching planes or scrolling through the slices, give the viewer a moment to render the image at full resolution. If a sample opens in an inconvenient orientation, the orientation controls allow you to flip the X, Y, or Z axes, like so. Or you can rotate the image in 90-degree increments using the rotate tool, which is the curly arrow icon in the toolbar. Once you click that, you will see the rotation controls. We have different options to make slight adjustments, or reset back to the original, or you can use these 90-degree increments to make quick rotations of your image. For a closer inspection of your image, You can zoom into the area of interest by using the zoom control on the bottom left of your sidebar. You can also use the zoom tool, which is the magnifying glass icon on the toolbar. When you select this and you left click, you will zoom in. If you right click, it will zoom out. Also, if you right click, you can press reset view to bring you back to the original. You can also pan your image by selecting this arrow icon on the toolbar. This allows you to move the dataset left to right. You can move, zoom in, and you can move the image within the viewport. These settings are purely to make the dataset easier to view and to navigate. For a more complete view of a region, select the 4-panel view. This brings the XY, XZ, and YZ planes together with a 3D view of the dataset. The crosshair tool, by selecting this icon, will link these views. You can click on a point of interest, for example, the heart here, and the corresponding location is immediately identified in the other planes. You can then use your zoom tool and panning tool to move around and locate the area of interest. This is especially useful when you see fluorescence in one orientation and you want to pinpoint the anatomical structure associated with that signal. You can also explore the CFT dataset directly in 3D. The first option is MIP, or Maximum Intensity Projection View. The MIP view provides an intuitive overview of the fluorescent signal throughout the sample. You can drag using your left mouse button to rotate the image manually, or press this play control for an automatic rotation. This can be a useful first step for identifying overall biodistribution patterns or areas that you might want to investigate more closely in the individual image planes. The second option is the MPR, or Multiplanar Reconstruction View. Here, the 3D anatomical planes intersect with the 3D volume. You can play the movie, or you can also pause. And here you can use the X, Y, and Z controls on the bottom left to move through those planes, helping you to investigate exactly where a fluorescent signal originates. Once you've found a display setup that works well for your dataset, you do not need to recreate it every time. The viewer allows you to save your current configuration as a saved view. Click on the view icon here to click on Configure Current View. Here, your selected channels, exposure times, lookup tables, display ranges, and orientations can all be stored within the dataset. Give the view a descriptive name and select Save View down the bottom right. And then the next time that you view this dataset, you can simply choose the saved view and your preferred settings will be restored. This is particularly helpful when returning to a dataset over multiple sessions or when you have established a consistent way of displaying subjects within a study. There are also a couple of additional tools worth knowing about. If you need to access a dataset somewhere with limited or unreliable internet connectivity, selected channels and exposure times can be downloaded for offline viewing. You can click on this icon here, and here you can choose the selected exposure times and channel settings and download for offline use. And if you would like to download the image volume into compatible external software, the viewer can also export selected data as MHA files for downstream workflows. Click on this icon here to export the volumes as MHA files. Here you can select the exposure time and the channels that you are interested in and click on Export. You'll find detailed instructions for both of these features in the EMIT Viewer user guide. And that covers the core features of the EMIT CFT web viewer. A simple workflow to remember is: start with the anatomy to orient yourself. Select and optimize the fluorescence channels you're interested in. Explore the signal through different slices, planes, and 3D views. And once you have a setup that works well, save that view so it's ready the next time you return. I hope you found this overview of EMIT's visualization tool helpful. Our team will continue to roll out product updates, new features and add-ons. The best way to stay up to date is by following EMIT Imaging on LinkedIn or signing up for our email list. For more detailed instructions, visit our technical resources page by scanning the QR code shown on the screen. And if you have any questions or would like to see your CFT data loaded into EMIT Viewer, please reach out to your EMIT point of contact or email us at info@emitimaging.com. Thank you for watching.